In question 17, we're told that a solid metal sphere has got a radius of 9.8 centimeters. We're told that the metal has a density of 5.023 grams per centimeter cubed. And we're told that Lynn estimates the mass of the sphere to be 20 kilograms. We've got to show that this is a reasonable estimate for the mass of the sphere, and we're given the formula for working out the volume of a sphere, the radius of r, so the volume equals 4/3 of pi times pi r cubed. That's not one of the formulas you have to remember. That's why they've given it to us. So if we start off with this question by looking at this word here, estimates, then we can round these numbers. These are horrible numbers for a non-calculator paper. So 9.8 centimeters, which is the radius of the sphere, is approximately equal to 10 centimeters. We round it to the one significant figure. We'll do the same with the density. So the density is equal to 5.023 grams per centimeter cubed, which is approximately equal to 5 grams per centimeter cubed if you round that off to one significant figure again. So we've got 10 centimeters and we've got 5 grams per centimeter cubed. What we need to do is use the 10 centimeters in the formula for the volume of a sphere. So the volume of the sphere is going to be approximately equal to, because we're using the approximate radius, it's going to be 4/3 multiplied by pi, and pi is approximately equal to 3, so I'm going to put that in straight away. 3/1 multiplied by r, which is what we approximated to be 10 cubed, so 10 cubed over 1. So we're saying the volume of the sphere is 4 times 3 times 1,000, because 10 cubed is 1,000, over 3, which is, we can just cancel the 3's out there and cancel each other. So 4 times 1,000 is 4,000, and that's the volume of the sphere. So volume is approximately 4,000, and this would be, because it's a volume, it would be centimeters cubed, because what we used as a centimeters for the radius, so centimeters cubed would be the units of our volume. Now we've worked that out, so now we've got that, we can use the density mass volume connection, DMV triangle. Right, knowing this, useful for this question, because to calculate a mass, which is what she did, you have to do density multiplied by volume. Now we know the density, or the approximate density, and the approximate volume, we can work out the approximate mass. So the mass is equal to the density multiplied by the volume. So our approximate mass is going to be equal to density 5 and volume 4,000. Now think about these units, that's 5 grams per centimeter cubed, and that is 4,000 centimeters cubed. So our mass, because of the grams per centimeter cubed, our mass is going to be in grams. Okay, and the mass in grams is equal to 5 times by 4 is 20, and then 3 zeros. So 20,000 grams, which we can then calculate to be 20,000 grams is equal to 20 kilograms. And we've reached the same answer as what Lynn did. And that's what we had to show, that it was a reasonable estimate for the mass of the sphere, just by rounding some numbers off, plugging some numbers into a formula, knowing the density mass volume formula, triangle connection, compound measures, and then working it out as she would have done, and knowing the conversion between grams and kilograms. So fairly simple maths, piecing it all together. You're getting 5 marks for that question. It's towards the end of the paper. It's quite a nice question.